Good morning, everyone, and a very warm welcome to this Energy Risk USA pre-conference webcast. The conference starts next week, but we're here today with a topic that touches all our lives. That's digitalization. We'll be asking, how can energy firms keep up with the pace of digital change? My name is Neil Palmer, and I co-head the Client Solutions team at Beacon Platform. It's fantastic to be here, and I'm thrilled to introduce a great panel with deep expertise and great insights to share. And of course, we'd love to have your comments and questions too. We'd love you to get involved. It should be super easy if you follow the advice on the screen. Now, let's meet our panel. Today, we have a fantastic lineup of senior executives and thought leaders from across the industry. I'm really excited to hear their insights and experience. First, I want to give a warm welcome to Adam Atkinson-Lewis. He's leading the commercialization of the energy platform at Shell New Energies. He's a big fan of clean tech and renewable energy. And Adam, you say on your LinkedIn profile, you're also a tinkerer, a fixer, and a maker. Can you enlighten us a bit about that?
Sure, and just goes to show you it's always dangerous what you put on your LinkedIn profile. Turns out everybody can see it. I wouldn't claim the title of tinkerer, fixer, or maker quite in the way that many of my Silicon Valley colleagues could claim it, but I like to make the occasional piece of furniture or light fixture in my house and have projects and fix and tinker with all the things that I have here. So I'm a fiddler, I guess.
Nice to have something physical to do as well as the, as well as the digital backdrop to our daily work lives.
Exactly.
Okay, great. Welcome, Adam. Next up is Glenn Mackey. Glenn's had senior risk and commercial roles at TD Bank and Nexen, and he's now the Chief Risk Officer at NRG, based in Princeton. He has a wide brief. He oversees governance and risk management and trade compliance, to mention just a few things. Glenn, I know you're based in Princeton, but I know you do a huge amount of travel, so I think we're lucky to catch up with you. Is that right?
Yeah, that is right. Thank you very much for having me as well. Appreciate that. And with being Canadian, working in the U.S., part of that travel was personal, part of that travel was business as well.
So in these times where the virus is impacting folks, it's not stopping you getting about?
I drive a lot more than I've flown in the past 6 months. I've taken one flight since February. I've driven probably 10,000 miles.
Wow. Amazing. Okay. Welcome to the panel. And I'm delighted to introduce Chetin Karakush, who heads up Quant and Analytical Solutions at BP. So he's building cutting edge risk and trading analytics, plus big data visualization, among many other things. Chetin, from your own profile, I see you had a substantial career in banking and finance before switching to energy. So I wondered, did you find it beneficial to work across a range of asset classes? Has that helped you in your energy work?
Yes, definitely. I mean, banking, I had a chance to work on the pricing and risk management systems firsthand, and that helped to building the similar technology for energy world and commodity space. Whereas in BP and energy space, you not only deal with the kind of what we call the paper financial trading, but you also deal with the physical trading. So that has its own complication when it comes to the operations and the physical implications, as people seen the recent oil prices going to negative, right, because of the storage constraints. I'm very excited to be in this panel.
Fantastic. Look forward to hearing from you in a little bit. And next on the panel, I'd like to give a warm welcome to Doug Wendler, who's an executive with deep experience in energy software. And 3 years ago, he founded Machina Automation. The good folks at Machina use their deep energy knowledge to help clients benefit from the best automation tools on the market today. Doug, you've successfully made the transition from corporate leader to entrepreneur. Can you tell us what drove you to create Machina?
Sure, and thanks for having me. So I suppose I've had an entrepreneurial bone in my body, most of my life. But we just saw an opportunity with, other industries that had made a lot more progress in the automation space. We just saw an opportunity to help lead, the energy industry into that market. And if you look at the advances that have been made in energy as it relates to automation in the last 3 to 4 years, it's come a long way. So, we just thought we could be an early leader.
Fantastic. We're looking forward to hearing some more about automation later in the webinar. And finally on our panel, we're very pleased to have Matthew Seacole from Microsoft. He's focused on the capital markets, and part of his role is to help educate firms on the journey to digital transformation. So Matthew, can you tell us a bit about how you go about connecting the dots between capital markets and tech?
Sure. It really requires a lot of learning. On a daily basis, I'm learning what trends are out there in capital markets and across various companies, and trying to match it up to what Microsoft's portfolio can offer, because technology can only take it so far. You have to find a solution or a problem to solve. And I've been doing that over my whole career since I started working at a cogeneration plant in high school. So I have a little bit of energy background as well.
Welcome. You've got a lot to catch up with then, a lot to keep up with rather. Thank you and welcome. So that's our panel. Warm welcome to all of them. I'd like to kick it off with a couple of personal recollections from my own career. I've been lucky enough to work for some really great energy firms, but looking back to the early days, sometimes I found myself wondering if we were always working in the best possible way. For example, sometimes I'd be pricing up a big transaction and my colleagues and I were emailing sets of market data back and forth. And you know, sometimes we'd be valuing a structured deal on a spreadsheet before it was executed. And when later it got booked in the system, you know, it seemed to have a different value altogether. So looking back, I would characterize these things as like a kind of pre-digitalized way of working. You know, lots of manual labor, risk of mistake, not sure we're collaborating using exactly the same input data, and please don't ask us to repeat the exercise with a different data set. You know, it's just a little bit, you know, not as connected as it should be. So part of the promise of digitalization is that we can perform these tasks in a much more scalable and repeatable way. So we'll be talking shortly about better ways of organizing analytics and also applying automation to these processes. You could call those the internal drivers of digitalization, because these are the things that help a firm carry out its current business in a better way. It's if you like, it's internally motivated to adopt these better techniques. But we'll also touch on the external drivers of digitalization. What's happening out there in the markets? What about the kind of data sets that we're having to handle? And what about the broader drivers, the social drivers, such as ESG, the drive for metrics of environmental, social, and governance? These things are driving us to work in a more digitally flexible way. And of course, we'll touch on something which is continuing to fundamentally change the way we work digitally, and that is the cloud. So a reminder, please, if there's anything that you'd like to comment on today, you're very, very welcome. We would very much welcome your input. And now I'd like to set the ball rolling by thinking broadly about data. You know, how data is changing, how it's posing new challenges when it comes to understanding and acting on it. Our life today is surely getting more complicated in all kinds of ways. Or is it? Well, we'll discuss that. And Adam, I'd like to turn to you first, please. So from where you sit in Shell New Energies, tell us, what do you observe? What do you think's going on?
Sure, thank you. And I'd say that I think our lives are definitely getting more complex. And thank you for having me, and it's great to be speaking with you all and other panelists as well. Yeah, so I think in looking at the title of this session, keeping up with the pace of digital change, the pace of digital change is very fast. It's very high, and digitalization is really all about, in this pace of digital change and evolution of the industry, is really all about reducing costs, increasing the speed of business and differentiation. And where I sit, it's really focused on, or really being driven by Shell's decarbonization goals, which are to be net zero emissions, 100% Scope 1 and Scope 2 by 2050, and 65% of Scope 3 by 2050 as well. And the platform that I work on is really at the heart of this need to be able to address large amounts of data and the digital change that the energy sector change that's driving digitalization that we're seeing. So at its heart, what I'm working on is a really scalable and flexible platform for dealing with data. How do you get that data? How do you store it, access it? How do you analyze and understand it? And then how do you act on it? And most importantly, how do you act on it to really make commercial value, generate commercial value? And so what does that really mean? Logging and storing and accessing data when you have a broad participation in the energy value chain, as Shell does, and will grow over time as we move to hit those goals that we have in decarbonization. You're looking at needing to be able to have globally fungible data models and methods for storing and accessing that data across the entire business. You can have and governing and other policies around personally identifiable information. You can really have a very robust way to really have all the data this business thrives on. And I'll get to the drivers of where all this data is coming from in a second. The next step in the kind of data journey towards generating commercial value is to be able to actually make use of that data through analyzing it, understanding it, generating insights from that data upon which you can act. And that means that you need to have really repeatable data workflows, different analytical tools, machine learning models, AI-fueled ways of really consuming massive quantities of data and flipping those into insights that can be actionable by non-technical people. I sit on the non-technical side. I work with a bunch of very smart data engineers and data scientists and software developers. And I'm the one who has to kind of be the idiot in the room sometimes and get them to help me figure out what I can do with all the data that they're figuring out how to store and access. And one of the ways that we really are able to build and act on that data quickly is through really agile and quick application development that sits on top of that data. And we actually use Beacon for that, which is a great acceleration for application development. And this analysis and the ability to have really rapid development of tools and insights from data allows you to really have a customer focus to all the work that you're doing, which is a big part of our growth at Shell New Energies. And then the next step
Hey, Adam, I wonder
really,
if I can just, so excuse me, sorry for interrupting, but I'm wondering if I can ask you, can you give us an example of one of these data? So, you know, what one of the streams might be, you know, I don't know, is it a particular category of energy information? I just wonder if you can, you know, give us put a bit of flesh on the bones.
Sure, yeah. So, and that kind of gets into what does this all have to do with decarbonization? The power, if you look at the power grid used to be very simple. It used to be a few power plants going through some power lines, going to the point where it was used. So a few to many. Now we have a big complex system that's evolving as we move towards decarbonization. You have some of those old power plants, but they're going away. You now have, and those old power plants are very predictable. You could know when they were going to be on, know when they were going to be off, dispatchable, flexible, or controllable energy. Now you have increasing penetration of wind and solar. And so wind and solar are intermittent. They're, can't control when they're going to be on and when they're going to be off. So you have to then have very sophisticated forecasting and data models around when is that wind going to be generating and how much? When is that solar going to be generating and how much? And building those forecasts takes huge amounts of data points. We did a quick calculation on the team, and one device in a 5-minute power market can, across that, getting data off of the device, moving that data into a forecast model, and then optimizing that forecast along with other generation sources or flexible controllable consumption sources can yield 28 million data points in one day.
Wow.
So you have, that's just from one device. And if you look at the massive expansion in the number of devices in our energy system, the amount of data that you're looking at just goes up to really hard to contemplate amounts. Wood Mackenzie recently forecasted that by 2025, we're going to have in the US 387 gigawatts of distributed energy resources. So this is looking at that previously silent consumption side of the power grid. And those 387 gigawatts of distributed energy resources some of them are going to be on the bigger side of a behind the meter power generation at a large commercial industrial facility, but a lot of them are going to be the Nest thermostat that you might have in your house, a controllable and the air conditioner sitting behind that, the vehicle charger that you have, your hot water heater. Looking at hundreds of millions of devices that can all produce data, be forecasted, and then be optimized off of each other to operate the most low carbon, least expensive and most reliable power grid, which is really the mandate that the energy industry has going into the future, at least on the power side. Yeah, so I think that's really the heart of it is this massively increasing number of devices that we have, and the fact that it's harder and harder to predict what's happening on the generation side, with 50% by 2050 of the global grid is likely to be made up of intermittent renewable resources. And then how do you balance off of that between storage, controllable load, and dispatchable generation? And the giant math problem that sits in between relies on a lot of data.
A variety of challenges there, and I'd like to invite all of the members of the panel. If you have any particular remarks or comments, please do feel free to chip in. But I mean, I think, Adam, you described very, very vividly these new challenges, and the amount of data that just one device can generate in a short period of time is quite astounding. So you need a range of skill sets, I guess, internally to deal with those problems. They're data technologists, and also new ways of processing the data. I mean, also from the user's point of view. So you've described yourself. I'm sure you're not the idiot in the room, but I mean, as a consumer, how have you found the ways to make sense of this? Are they successful? Are they just overwhelmed by the amount of input data there? Have you also been successful in being able to boil it down to some actionable advice?
I think as a consumer of the service or the device in your home or in your business, this needs to be as invisible as possible. If you need your home to be cooler, it should be cooler. If you need your warehouse to have brighter lighting and you want to turn it on when you want to turn it on versus a schedule, you should be able to do that. So at the end of the day, this all just needs to be quite invisible to the end user. And that's part of the challenge sitting behind it of the forecasting. And when you get these larger and larger pools of devices, you can start to build in predictions for this type of variability and have those predictions be based on models that learn over time and improve over time. So, and digitalizing energy firms and turn it into reliable services and offerings, so that the end users don't have to think about it at all.
Thanks, Adam. Let me just check if anyone on the panel would like to comment or contribute on the topics that Adam's been mentioning.
Yeah, I think the data challenge is one that every firm, energy and non-energy, are facing at the moment. And what we're seeing out in the market is customers are starting to look at sustainability in the context of the compute data and artificial intelligence that's required to do it. So what's on the back end doing all that work? So while we're trying to eke out more sustainability efficiencies, what is the technology really doing? And are we really getting that return on our sustainability investments? Because that's requiring a ton of computers, which are being powered by the energy grid, and downstream and downstream and downstream. So it's definitely, like, I think Adam framed it perfectly. It's a huge math problem, right, to figure all this out.
And it takes somebody sitting at Microsoft to remind us, of course, that the cloud is definitely not a cloud. It is a lot of very high energy intensity buildings. you have to think about what's happening there every time you send some sort of request to the cloud. And thankfully, a lot of the decarbonization effort in the industry is being led by the cloud operators.
Well, I think that brings us nicely to another focus. So Adam has set the scene for us vividly with a discussion of modern data processing challenges. And we've also just mentioned the cloud there. So I wanted us to look at cloud as a little sub-theme now. And we're going to, in particular, look at one firm's journey in this space. So I think you could say cloud, by the way, is both an internal and an external driver of digitalization. Of course, it makes sense from an internal perspective, cheaper compute and storage. Who wouldn't say yes to that? From the external perspective, the growth in the number of public cloud providers. We have Matthew's firm, Microsoft, with us on the call today. The very high level of public acceptance now of the cloud. These mean quite big changes in the social and economic landscape. So actually, I'd like to turn to Glenn to give us some more insights on this. Because Glenn, I know you've been spearheading the journey that your own firm, NRG, has been making onto the cloud. Can you tell us a bit about that, please?
Okay, so first and foremost, it wouldn't be a unilateral spearheading. I wouldn't want to be on the tip of that one because there are a lot of challenges and barriers to moving any of these sort of digital platforms or technologies forward. So, but I've been a strong advocate alongside of my colleagues, especially in the IT group, to do that. So if I look back to when I joined NRG back in 2011, one of the first conversations I had was with one of the quants that was in the risk analytics, wholesale risk analytics team. Those of you that are not aware, NRG, the company that I work for, we've got a fairly robust portfolio of everything from coal assets, which were spoken to earlier, to wind and solar, distributed assets as well, gas, nuclear, et cetera. So across the energy grid and the energy stack, we've got exposure there. And one of the leading analytics fellows in the office came to me and said that he wanted to work on a contract to obtain cloud computational storage, if you will, because he liked the idea of having the computational horsepower involved in having the data all in one repository. And so, knowing not much about this at all, I said, let me get back to you on that. But it really was something that's evolved, and my observation would be is that I think a lot of different market participants are evolving. And at the time and that was 2011 when I had the discussion with the head of IT, the short answer to that is no, we're not putting any of our information, public or like market information or private information, on somebody's server outside of our own environment or control. It was a hard no, to say the least. And so now, you look at that evolution, that has obviously softened. One of the challenges that we had as far as barriers was really around the privacy of the information and data. And there was a lot of discomfort. Just a lack of knowledge drives a lack of comfort, if you will, and an understanding or lack thereof is sort of tied hand in hand. So what essentially I had to do is find a strategic partner to first obtain a big data set. And the driver really wasn't initially cloud, it was more around big data. Everybody was throwing out big data on their earnings calls. And so it was a top-down CEO mandate that we need to understand and have, we need to be on the forefront of some of this stuff as well. So, initially big data to a lot of, utility companies in the energy space really meant that you had some sort of front-end tool that had graphical capabilities that would knock your socks off. And it really didn't matter where the data was warehoused in the back. It was really around the display and the user interface and the actual output. And so that sort of evolved into an actual mandate to say, hey, if you think about the market liquidity for commodity trading and the way that data is used now, the ability to seek arbitrage opportunities within the marketplace is really driven on information, having it in a real-time basis across the market, and either looking for locational spreads, time spreads, some sort of quality spread in the crude and the liquids market, but having some ability to find and seek and arbitrage that opportunity before anyone else does that. And so from a risk standpoint, we decided that analytically to bring in, a large data set of real-time pricing information was the way that we wanted to step into that space for two reasons. One, it wasn't our own proprietary trades. It wasn't our proprietary data, so we could get our company, our IT infrastructure and team, comfortable with it. But ultimately working to then the ability to have low cost, computational and storage resources that are our ability to feed the engine of the commercial teams. So that was the initiative. The drivers were not only just low cost and, the computational horsepower, but also, when I posed and said, well, hey, what if we do this on servers? The answer to that was I'd have to kind of check for about and build into the budget about $10 million.
Wow.
That was a hard no as well from my standpoint. I hadn't budgeted, nor did I want to wear that for something that was relatively, a proof of concept sort of pilot issue. So the challenge was finding a strategic partner with the data, and then also strategic partners that would help us build out and re-engineer software and the infrastructure within our organization to actually utilize the computational information and data access that we were negotiating with a service provider. And it, serverless computing and sort of structured query language databases was not our area of expertise at the time. So we got learning on that. There again, though, the big drivers and barriers, to us was really around data privacy. That was first and foremost. The complexity of the data itself and understanding and mapping all of the data, and then also the regulatory compliance that was necessary, both internally and externally. And any time we're sharing some of the information, especially sensitive price information or consumer information. So that journey was fairly substantial. At the end of it, I'd have to say that it is a transition and a continual journey. It is not something that we've seen as an end state, but part of a process around digital transformation, really focused on both communicating better with our customer base and improving the communication internally as well. So that is sort of the overall journey that we came across. And to this day, we're still working with our vendors to update their software platforms, if you will, to allow us to have the ability to access and feed data in from the cloud. And that involves sometimes actually placing the software, depending on the computational requirements, embed that right in the cloud itself versus having it as an external and pulling down the data from the cloud. So it's not necessarily my area of expertise, but I feel more fluent in it now than I did 10 years ago. Let's put it that way.
Glenn, thanks so much. That's a very nice telling of the story. Interesting how it was a hard no to some of the more sensitive information. So you go around that and you look to market data, real-time data, where you can store large quantities of data and hunt for those pricing dislocations. And so I guess attitudes have changed and knowledge has grown internally, and so the categories of data that you can put in the cloud now, they do include some of the more sensitive aspects like customer data that you were mentioning. Is that correct?
That is correct. What we're finding is that because of I put it this way, a company that is sole focus is on data management and protecting data privacy invest more capital in that than your typical commodity or company itself, because of just it's not an infinite amount of capital to do that. Those companies have more at risk, and Microsoft Azure essentially is the one cloud that we decided to go with. And Microsoft is all right. Might as well throw a plug in there for them. But really, our comfort level in their ability to understand and keep up with not just the privacy aspects of it, but also the attempts to break down that privacy through a number of different ways where you've got third parties that are just trying to crack in. We felt more comfortable and have gotten more comfortable over time with their ability to manage that than our ability to internally manage that. Not because we don't have qualified and competent individuals, but just the sheer volume of money and information and knowledge to manage that on a continual basis is something that's not our core skill set.
I see. Let me remind all the members of our panel, if you want to chip in and make a comment, or or to jump off something that Glenn has said, please feel free. I'm just wondering myself, Glenn, can you comment, where does the balance sit between sort of, storage and like compute analytics? Do you have a sense as to, which is the dominant factor right now for NRG in the cloud, or are they equally important?
I think from our perspective, they're equally important. What we see, though, is there is a lag between access to the information and the data in the cloud and being able to put that information in the cloud and feed that on a real-time basis and have fairly large volumes of data, and the tools that we've been accustomed to using in the energy sector for the computational aspect of it. Those vendors have typically been on hard-coded, programs that are not configurable, and that has been challenging and problematic for us. So working with our strategic vendors has been the last few years the key emphasis there, so that we have the ability to do that. Anything that we can code in MATLAB or R, or do it in Python, or potentially even just use Microsoft Power BI to pull information and do it in a fairly efficient manner. We are doing that internally, and we've even set it up so that when we're recruiting for risk professionals now, there's an expectation that you have your risk skill set and experience, but also that there is a programming aspect or component or a data or architecture understanding as well, so that we are hiring for the future, because the explosion of even the human capital element is really migrating towards more an ability to be tech savvy and work with the information and the data, more so than understanding the core business and core requirements of the business itself. So that's we've seen that both in, if you look at stats around earnings calls, where digitalization, cloud computing, and all these other things are referenced, it's exponential in the last few years. And this, if you look at stats around hiring for certain key areas, especially in the finance organization, that's becoming more and more critical as well.
Wow, how interesting. So like tech and coding skills are almost more of a key entry requirement than the sort of traditional commercial awareness and business skills.
I can assure you that I would not be hired today for the job that let's put it that way.
I fear I might be in the same boat. Okay, let me just ask the panel, any quick comments on the broad topic of cloud? We've got a few other exciting topics that I'm anxious to move on to, but just in case anyone from the panel would like to sort of take any angle there.
I could talk about
not cloud, but he mentioned about this arbitrage monitor, which kind of rings bells with me, because we built something similar where we have traders who are kind of monitoring the markets, oil markets, on tens of thousands of different grades, location, time windows, like contractual obligations, and those can create some arbitrage opportunity. You can buy something cheaper in one location and deliver it in another. So usually this is done by traders' own knowledge and kind of a manual processing. But if you build a kind of a real-time arbitrage monitoring application, you could essentially monitor those conditions and then bring up some exceptions report window so that they can target their account much more efficiently. And that is definitely a real P&L generator.
Yeah, the one thing I'll say on that is that the challenge we had with we didn't factor in initially, but we've overcome it twofold. One is the fact that anytime you're doing that, especially with types of products that are exchange traded, for example, where you see arbitrage opportunities even within an exchange between a nice product and a nice product, maybe a weekend product versus a Belmont product, et cetera, where you can eke out some value propositions, obviously subtracting the friction costs associated with the trade itself, is that raises some flags from a regulatory front, whether it's a CFTC, whether it's exchange themselves, FERC, or other bodies do express a lot of interest in transactions that do create value for the organization, but are arbitraging system inefficiencies or data inefficiencies. And the second point I would make and counsel to folks is that if you plan on doing that, make sure at the end of the day that there's actually a trader pressing a button so that you actually can point the finger at somebody and say, did you do this trade? Why did you do this trade? And don't just say, because the algorithm told me to. That's just not a good answer for anybody internally or externally. That was my learning for not personally, but learning from some of the other industry market participants that we got pulled into.
Definitely.
Hey, Glenn.
We call it arbitrage monitoring. So it kind of generates exception reports. It doesn't automatically execute the trades. The traders have the final control.
Glenn, I just want to relay a question that's come in from Dawn Golden. Dawn, thank you very much for your question. It's a question about NRG, and Dawn asks, to what extent is NRG using machine learning and AI as part of your analytic approach?
Okay, first and foremost, I don't have a safe harbor statement, and you didn't put one up for me, so I'll start this by saying this is my personal opinion, not a reflection of NRG's sort of situation. So when I think of how NRG looks at the digital age and how we look at information from both an external and an internal perspective, it's really around streamlining communications. And I apologize for the background noise here. Forgot to turn my phones off, so bear with me on that. So internally, it's really about channels between groups and finding process efficiencies. Externally, it's really around customer expectations and meeting with both customers and third parties. So that's sort of the digital approach. As far as how we do and interact with machine learning, I would say cautiously. Robotic process automation, we look at that as the practical applications that we see within the sort of the digital transformation, if you will, or the 4 key areas that I see personally, of course, not NRG, but personally, but would have a tendency to influence some of the things we're doing internally, is around blockchain, artificial intelligence, the Internet of Things, and then robotic process automation, or RPA. And where we have opportunities, and we have an internal team, and we also have external consultants that help us with looking at our processes. If you think of about a commodity transaction, everything from deal capture through to straight through processing, there's really nothing straight through or simple about it. It touches multiple systems, your ERP systems like a SAP, for example, your ETRM platform, your customer relationship management platform. You've got volumetric and inventory systems, rail transport for coal, a bunch of different infrastructure there. And finding pieces of that process that can be automated and replicated where there's a standard requirement and doesn't deviate, it's not a dynamic process, is really focused our efforts on the RPA side. And the AI and the machine learning aspect of it, that's something we're treading lightly. And just given the fact that our business model, or the company's business model, is really around sustainable and predictable earnings, we don't want to do something that has unintended consequences. So we're very cautious about where we implement any sort of machine learning or artificial intelligence. We use that for more the analytical things and research around either the customer portfolio, our wind portfolio, our solar portfolio, and ability to enhance our economic decision making, but not necessarily materially impact a process that has some sort of tie to the actual cash in the bank that flows through to the would be
Okay, thanks so much, Glenn, for that response. And in fact, you mentioned RPA, robotic process automation. I'm looking forward to hearing a little bit later on from Doug, who I hope will be telling us a lot more about that. Glenn, thanks so much for telling us the NRG's cloud journey. At this point, I'd like to give a quick reminder to everyone. You're watching a live pre-conference webcast ahead of Energy Risk USA next week. We're talking about digitalization, and how can energy firms keep up with the pace of digital change? So far, we've spoken about data and the cloud. Now let's move on to analytics. How should you think about linking the data and the analytics together? I'd like to turn at this point to one of our panel, Chetin, for some thoughts on this. Because Chetin, you've worked closely with trading and risk system development. Perhaps you can share some thoughts on linking data in a dynamic way with the calculations to give us rich analytics.
Yeah, happy to do. I think I'll start with telling, for me, digitalization is mainly, well, it's not all things, it's mainly three things. Automation of the business processes in terms of systems, so you can run them. Then integrating those systems together so they can talk to each other based on a certain protocol, so they can communicate, so they can cooperate. And then operations of this landscape. So you're going to have lots of systems, they are kind of talking to each other, and there'll be obviously lots of operational things. And all of this will take place on a plane of systems, data, and analytics. So when you look at the big organizations, you see that we can talk of like workflows or pipelines where data is coming from one side and people, teams, system working on it get transformed and moves into the next stage, and then ultimately it kind of lands on some decision makers' screens. So these are kind of pipelines, and when you think about there will be like tons of this pipeline, thousands or maybe hundreds of thousands of these pipelines in a big organization, and those pipelines kind of make up what I call it the graph, right? So it's essentially like a directed cyclic graph, where each node might be corresponding to a system or team's activity. And now, we've been like, with the use of computers, we've been kind of automating those individual steps, for a long time. So there's nothing new there. What's happening now with the advancements in the technology, you give the ability to people to actually see the kind of a bigger part of the pipeline. I'll give an example, for example, from the derivative pricing domain. So with derivative pricing, we have pricing applications traders are using to price options, and those pricing models requires volatility surface and discount curve, forward curves, the data they need to use to do the pricing. Those curves themselves, those surfaces, actually built by a separate team based on certain methodology, and they are themselves are output of certain systems, right? So you will usually get the end of day run, build those curves, and then give to the traders next day, and they will be using that during the day to kind of price their options. So with that, they can do the pricing, they can shock the curves, so they have some ability to see kind of how the dynamics of those inputs affect the pricing process, but they don't have the ability, if they don't have the whole picture of the graph, they won't have the ability to see the kind of individual part of those in the curves, how the individual parts affect the pricing process. For example, you might have certain future contracts or bond futures that might be used to build the forward curve of the discount curve of the US dollar, for example, and then you use that to price your options. So what happens if there's some market dislocation in a particular instrument, and you want to see the kind of effect of that to how that's going to affect your pricing assumptions or the pricing results. The only way you could do it is like you wait for some risk management teams kind of building those curves and feeding you. Whereas if you have all these kind of all those parts of the pricing process are kind of a graph available to you, you could basically go and manipulate those individual parts, and then you could see the effect immediately. Same thing with volatility surface, right? So you might look at the individual option contract and you can see the impact of that in the pricing process. So this is not just specific to the derivative pricing. I mean, this could be done for other domains as well. Like another example I could give is like real-time logistic optimizations. For example, we have like a big shipping fleet, and we're kind of doing trading LNG, where we're kind of moving the cargoes around the world from one location to another based on our contractual obligations, and also based on the fact how much we can, based on how much we can realize when we sell in different markets. And the market data kind of constantly changes. There are kind of operational changes where, there's port restrictions, sanctions. So you kind of combine all of those into a kind of a one optimization systems, and you use that not only be able to kind of spot trading into this usually long-term traded contracts, but also you can see the impact of what will happen if there's some sort of trade disruptions, or the prices suddenly kind of jump up into certain locations. So having all this thing into one system through a graph allows the actual traders to kind of run those simulations themselves. So they don't have to wait for let's say some sort of risk team to kind of run some scenarios overnight and then provide them. They can actually go and to change the certain part of the shock, a certain part of the graph, and then that kind of triggers the other parts of the graph with the dependency relations, and they can see the impact. They can see, well, what will happen. So what if analysis? They can create scenarios. They will prepare. I mean, they can't predict what's going to happen in the market, but they can think about the different scenarios and the implication of those scenarios, and they can be ready when that one of the eventualities certainly materialize. So you could adopt this, I think, with all the data technology across the enterprise. Like you could turn all your flows and pipelines into this kind of graph, and then provide this technology to your decision makers, and then they will be in the kind of a driving seat where they can go and run experiments. So I think that's one of the things, for example, I'm trying to do in BP with our system, is creating a kind of experimentation platform. So you get all the data, you generate analytics, but we also give abilities to people to essentially create experiments, come up with hypotheses, and then test those with the data and see the implications of the certain scenarios. And that's very empowering.
That sounds amazingly valuable, especially in a physical trading context. I mean, you said you don't need to wait for the risk team to create a different scenario. The traders themselves, they can, really on the fly examine, what if, or their sensitivity to certain changes in the inputs. I mean, you've got so many things to worry about, so many dimensions, things going on. I wonder if you can say this is like bringing the data to life, because you have a sort of, a live link from the inputs, the many inputs to a calculation, to the outputs.
Exactly. I mean, data become valuable when you generate analytics. Right? So everyone is kind of, I think, agree that you need to generate some report visualization. That was happening. I think with the digitalization, you see that this kind of experimentation as well. So you kind of play with the data, you create scenarios, you see the implications of those in your systems, and how it's going to affect your key deliverables, key metrics, and users can do that. So we have like thousands of users. You expect like hundreds of thousands of scenarios being created. I think this is what data-driven should mean, right? So you basically then can make your decisions based on the data and the different scenarios, not just like, gut feeling or, like this is how things used to be like that. You could actually create scenarios and see, okay, if this outcome, if this might happen. And then the question becomes like, what kind of, probabilities subjective probability you assign to different outcomes. I mean, still you will have a kind of array of options, right? When it comes to what will happen in the world.
Thanks so much, Chetin. Again, any other member of the panel, please do feel free to chip in. And I'm curious at this point because, Chetin, you've mentioned two examples. You spoke about a pricing example in the world of derivatives, but also logistics and physical trading. And I'm thinking also of topics like automation. I mean, it's not quite the same thing. I think we're going to come on to robotic process automation, but I think what you're hinting at, Chetin, is thinking modularly, breaking things down into components so you can actually make this graph where you connect the different stages of the calculation. And I'm wondering, I'm wondering if there are benefits here around also automation, leading to greater operational accuracy and less risk. I don't know if Doug, that's something you can speak to, because I know that you have sort of you're really in the zone of automation.
Yeah, I mean, sure. We have actually seen clients who have used RPA to enter schedules, and as you mentioned, the accuracy level is perfect, and the speed is very rapid. It frees up time for the people that are doing those activities to focus on exceptions and focus on more valuable things. So it just depends on a customer specific environment and which who they're nominating with and who they're scheduling with and who they're confirming with as to how much value they may reap out of that. But absolutely, if you train a robot to handle a scheduling event, it's going to handle it exactly the way you told it to handle it, and it's never going to complain about it, and it's always going to do it on time. And so there's a lot of value in that. And the exceptions pop out quickly, and you can work those and just be more efficient. So.
Super. Thanks, Doug. So I'd also like to thank Chetin for giving us a summary of, his thinking on, connecting data with analytics and thinking in a graph-like way. I mean, that's actually a thought process that we in Beacon Platform like to do and find also a very powerful approach. And moving on now, so I mean, Doug, you've made some introductory comments already about automation. Thanks for that. And one of the most valuable forms of automation is RPA. So if you haven't heard of that acronym, it stands for Robotic Process Automation. So Doug, you founded Machina Automation to deliver RPA to the marketplace. Can you tell us a little more about it? I mean, maybe put RPA into the context of automation more broadly.
Sure. Yeah. So, we actually are focused primarily on RPA with a little bit of a bent towards machine learning as well. Although most of what we think about from a machine learning perspective is just getting prepared for it. You hear people talk about machine learning and AI kind of as part of the evolution of digitalization or digital transformation. And, really machine learning and AI is all going to be based upon data. And so we think about RPA in addition to some other things I'm going to tell you about here in a second. We also think about it as kind of the foundation or laying the foundation for the data that you will need to make accurate decisions from a machine learning and AI perspective down the road. So we see RPA as an essential step in any company's digital transformation evolution or AI evolution. So now if you just kind of boil it down to specifically around robotic process automation, a couple of the other panelists here have mentioned some use cases that definitely, were right on the mark. Focusing on use cases where the data is consistent, the rules are consistent. If there's complex amounts of data, that actually tends to bring even more value because robots can sift through lots of data very, very quickly and very, very accurately. We've seen customers focus on kind of three different areas broadly. Most companies tend to start in the back office and focus on finance and accounting processes. The data's stable there. There's not a lot of risk. You can compare it to months and months or years and years worth of prior runs of the same data from a manual perspective. And so there's a lot of ability to really feel comfortable that you're getting it right. In the back office, we've seen customers focus on simple things like invoice reconciliation, bank reconciliation, any kind of regulatory filings. Regulatory filings are the same every month or every quarter or every year. Sales and use tax filings, things like that just take a mound of work off of people's plates for a lot less money and a lot less time by using robots to do it. then we see companies move into the operational side of things. They generally are focused somewhere in the order to cash process. I would even see scheduling and confirmation, like we talked about a moment ago, as being part of the order to cash process. But focusing on the things that get information in and out of your ERPs, because as you know, most people who have worked with SAP or Oracle, it can be fairly complex to get a fairly simple piece of data into an ERP in an effective way. You can use robots to handle that on a much more efficient basis. And then the last piece that is kind of newer is the concept of citizen development. And you'll hear that term, or you'll hear a robot for every person. The idea is to put a robot into the hands of every user in an organization, much like you would a spreadsheet, much like you would a cell phone. And that over time, people will learn to use those robots in a way that make them anywhere from 10 to 30% more efficient by taking their own tasks and automating them on a daily basis. So if I'm a person who has to go to 6 websites every day and gather, a bunch of information, analyze that, and then make a decision or turn it over to someone else in the process or in the workflow, there's no reason that you can't have a robot do that every day for you. And so those are really the kind of the high level things that we're seeing people focus on. I mean, the amounts of time and therefore money and productivity and efficiency and accuracy that can be gained by leveraging RPA is really astounding. I mean, it's really phenomenal.
And so I guess that translates to a better customer experience as well when firms adopt RPA.
Yes, I mean, certainly if you do it correctly, yes. I think, and that we like that side of it because that tends to drive more revenue. I mean, a lot of times you hear RPA can be associated with cutting costs. We don't love the idea of that, but frankly, in the market that we're in right now, with oil prices being where they've been, frankly, a lot of times we're helping companies that have already trimmed their workforce, be able to handle the work with robots rather than having to bring the entire workforce back. I mean, because frankly, in a lot of cases, that's not financially feasible. Mm-hmm. And so it's a financially feasible way to do the work, to take a lot of work off of the remaining people. Like we see companies today where people are working 16, 18-hour days to cover for the folks that are no longer there, frankly. And, RPA can take a big burden off of those folks. And then to your point, the quality of the information that gets back to your customers is going to be better as well.
You mentioned citizen development. I mean, I would love the idea of my own personal robot to perform repetitive tasks. Can I ask you to take out the crystal ball and say, is there anything else that you foresee is going to be on the horizon and coming up in the world of RPA? And anything that we should look out for?
I wish I had a crystal ball, but I'll do my best. No, I do believe that, I believe and see occurring as we speak, the idea of a robot for every person. And I think if you were to go survey the market, you're going to find that a very small portion of the market has adopted that so far. Much like if you go back just 3 or 4 years ago in the energy industry, very few companies had adopted any aspects of RPA at that point in time. And now it's fairly common across the industry. So I do believe those two pieces are coming. And then I think beyond that, it's going to be a focus on machine learning. And I just think it's going to take, more time for practical applications that are safe. As Glenn mentioned earlier, some of his examples, there's not a lot of comfort in letting a robot run with what it learned today with your business. But that's really probably no different than what we thought about the cloud, 5 to 10 years ago, where, as Glenn mentioned as well, it was a hard no, right? And now it's softening. And I see the same type of trend as it relates to allowing machines to act on our behalf, whether that's with RPA, which is, not super intelligent, frankly. It's super horsepower for, for repetitive tasks. I see that evolving into allowing machines to work on our behalf with things that the machines learned, which ultimately is AI. And I think AI is going to take, maybe even decades to mature. But I think machine learning is probably within the next 5 to 10 years that you'll see machines, acting more and more on behalf of businesses.
Fascinating and very exciting. Again, any other member of the panel that would like to chip in on those points, please now is your chance.
I will say, like the automation that's done through the RPA, that could be the nose of that graph I was talking about. Like people can automate some of the steps in their work processes, and then you could just put them into the graph so that you can run the whole thing end to end. And that will be one way to kind of empowering the normal users to kind of play in the whole kind of a digitalization process.
Yeah, and I would say that in that example, Chetan, you have the benefit, let's say it's a citizen developer automating those pieces. You have the benefit of that same developer, which is a human, vet and validate the data in the steps as you go through it. Over time, once that user has seen that data be correct every time, they're going to want to stop looking at it. And that by definition is machine learning. That is the machine getting smarter and smarter by human input.
Thank you so much, Doug, for giving us a broad perspective on the work of Machina automation. And I'd just like to remind everyone watching this live webcast, please do submit questions. We'll tackle a couple of them at the end. There is one major topic that I would like to turn to now, and that's the need for metrics around social factors. So let's put that in context. So far, we've covered a whole range of topics: data, cloud, analytics, automation. But now let's add the important social context. And a key external driver for greater digitalization is ESG. So that's environmental, social, and governance factors. And in particular, investors are demanding metrics. That is the game changer. And I'd like to turn to Matthew Seacole for a perspective on this. Matthew, tell us what you're seeing.
Sure. So in capital markets, what we see is the exact focus that you're talking about, Neil. We see in institutional investors and even hobbyist investors starting to seek out ESG, especially around what's going on with COVID. And in March, I think it was, we saw news articles come out that ESG was outperforming the S&P 500 on average by 3%. So it got a lot of attention, and it has continued from March on. And for energy firms, this represents a unique opportunity. And we've heard it across really all of the panelists today, from the foundations that need to be in place, like Doug was talking about, through the complex data, AI, risk management processes that everybody else was talking about. For energy, it really represents this inward-looking piece where they're taking a look at their own sustainability, their own safety in their workforce, which hits right on that S part of ESG, the safety of their mineral operations, their mining operations, things like that, all the way through transparency of the corporate board. But there's another opportunity out there that often gets overlooked. And this is the opportunity to give companies an understanding of how they're impacting the environment through the energy that they're consuming. So you might think of this typically in the form of control systems that operate buildings or transportation systems maybe, but it could, right now there is kind of there's a lack of this centralized data set because I think Glenn or maybe Chetan said it earlier, or actually it was Adam, there's so much data. I mean, imagine what Adam was talking about with that 28 million data points at scale across every firm on the planet, and then trying to figure out, well, what does that mean for Microsoft's energy usage? Energy firms have an opportunity to help surface that information back to the companies in a new way and potentially build new revenue streams out of that data. Because these capital market firms right now are purchasing data sets around ESG, trying to figure out really, how can we identify the risks? Which companies understand their ESG risks? And for energy firms, it really represents that opportunity to say, I understand your energy risk because I'm your supplier, and here's what that means for you. So that's kind of where I see this going in the long term.
Matthew, thank you for that. We have a question that's come in from Steve Fields. So Steve, thank you very much for your question. And I think it touches very closely on being able to quantify metrics that relate to things like our carbon footprint. So Steve's question is, you gave quite a long question, Steve, so I'll try to get it, I'll try to read it correctly. Steve says, how can we decarbonize when we don't know our current carbon footprint? We've made great progress on the easy bit, that's decarbonizing the grid. But organizational decisions are taken by accountants based on financial considerations. We need a new cross-sector approach to putting carbon into our decisions, where one organization's activities, like putting more EV chargers in place, will offset carbon increases in other organizations, like additional load and associated losses on the grid. How can we enable that? So it's like a really taking account of more emissions and less emissions there. Any comments, Matthew?
Absolutely. So I think you've seen this with Microsoft's own approach to sustainability, which we've had two announcements this year that were pretty major, where we're holding not only ourselves accountable for sustainability, but also our suppliers. And that involves taking a look at downstream suppliers' data. So we're talking about those scope 2 and scope 3 emissions. And this, Steve's right to call it out. It is a huge challenge that no company can go at it alone. It's just too massive. And so you need to take a look at your business, how your business operates, reach out to those suppliers. And again, energy is a supplier. Understand your own portfolio and provide that back to the companies that you serve so that they can understand what they're doing. I think what Steve's touching at is the ultimate end state of this, where sustainability becomes kind of like a marketplace where you really, it's almost like a data marketplace where you understand all of these factors that impact a company's risk ultimately.
If I could maybe even supplement those comments, my observation is that the financial institutions already are doing that analysis in their commercial portfolios, such that they're taking into consideration the carbon footprint and the carbon and other, sustainability and diversity factors across the board into the decision whether they are going to lend or put you into their portfolio, because the banks are now having to face both regulatory and internal portfolio standards that are driving economic decisions around who they lend to. If I was the owner of a coal company, for example, right now, and I needed financing, the probability of having an institution that has sustainability metrics embedded in its internal performance metrics or a regulatory requirement is not necessarily going to take on that sort of risk in the portfolio. So we're seeing those drivers even in the questions that we get when we're looking at going to the market. Anyone with capital, whether it's equity or debt today, is looking at that as a driver for economic decision making on whether they invest into that particular company, industry, or marketplace.
Can I chip in? I think this is a question we actually discussed in our rehearsal last week, right? I think it has to be kind of done in a kind of more fundamental way, just like we have these financial statements for the financial health of the organization. You need to have similar thing for the carbon footprint, like carbon balance sheet, carbon flow statement, where that will necessitate to keep track of all the carbon related activities across the organization. And then that will just go up to the very high level. And then you can have
I don't see it as a company-wide issue right now. It is a marketplace and industry-wide issue. It's well beyond any particular company's requirement. I think that's where we were going earlier.
It has to start from companies, right? Just like you look at the health of an industry from the companies operating in that industry. It has to start from the individual company.
Well, it's actually starting with regulatory bodies actually that are driving some of this. It's not starting within the companies. The companies are actually reacting to what some of the regulatory requirements are. Your company and my company fill out questionnaires on water and water sustainability and water usage, et cetera, that have nothing to do with our internal drivers at all.
Yeah, I mean, I agree, but the regulation is going to be saying that you have to report your carbon, balance sheet or your carbon flow statement in a kind of a very accurate level, and that will require companies to starting to, in their operations and their business activities, to have record that information. Right? Without that, you won't be able
We're
to
doing it already. Yeah.
If I could chime in and take off my present day Shell New Energies hat and put on my prior life energy policy guy hat, the question is really angling towards is something that looks like an economy-wide cap and trade style policy where you have regulation, per what you were saying, Glenn, really that covers an entire economy or significant swaths of it, causing those triangulations to be made between what is this one activity over here versus another activity in a completely unrelated sector, a completely unrelated company. How do those impact each other in terms of a net carbon footprint? Well, if there's a cap and an economic signal, a price signal between those two things, that starts to happen. So I think there's a lot of work that's been done in this world, a lot of great policy design, but not a lot of political feasibility, depending on what country you're sitting in.
I think some of the regulatory challenges that we face too, and even as the metrics that define what those measurement tools are challenging. So to give you an example, as a company that produces, electricity from coal-generated assets, our strategy is to reduce our carbon footprint. One of those, opportunities to do that is to divest, coal generation assets to do that. Unfortunately, with the metrics in today's environment for reporting to third-party regulatory bodies, if we divest an asset this year and we reported last year that we had that asset and we see a net reduction of 100 units, unfortunately, for purposes of, because the broader context isn't there, for purposes of reporting, we have to remove that asset from last year's reporting. We can't show the net benefit, even though there's an economic benefit and a sustainability benefit to our particular company, because it's just sold to someone else. The net is set up such that it's zero, which I think is a good thing. But the only way to solve these type of solutions is to work in a situation like Microsoft is doing, where they're pushing it downstream, and that you have the entire flow from, the creation of the carbon to the retirement of the asset obligation, through the full nuance of whoever is actually even touching or creating or reducing that footprint.
Yeah. And I will say that just like we have GAAP for accounting, we will need something similar for the generally accepted carbon accounting practices, and that has to be enforced. So the companies start to paying attention to their carbon implications of their operations and activities.
If they don't, they won't be around. There's no...
You're fine, right? It's like if you don't report, your accounts correctly.
I think that's problematic.
Yeah.
Gentlemen, thank you. Thank you very much. Very interesting comments there. I'm minded, myself, as you might have guessed, I'm on the other side of the pond, but in Europe, for some time we've had a cap and trade system in carbon emissions, and turning that into an economic, like a marketplace. That's Matthew's comments on like a market price for these for these ESG metrics put me in mind of the emissions trading that we have seen in various parts of the world. Matthew, thank you so much for bringing the social context onto the discussion today. Very lively discussion that led to. We have one more question that's come in on a slightly different topic. I'd like to turn to that now, and it's another one from Dawn Golden. Dawn, thank you very much. And it's specifically mentioning you, Chetan, and looking at dynamic analytics. So let me just read out the question. So the question, Chetan mentioned some very dynamic analysis of charts, which sound compute intensive. Does BP use cloud providers for this, or does BP use its own high performance computing system?
Okay, I mean, the answer to that, like, we use both. So we have a kind of high performance computing center actually in Houston where we do for upstream type of geophysics simulations and some weather simulations. And we also use, we have a kind of a compute grid for doing the derivative valuation, which is currently on AWS. But some of the systems we built is actually can run on the people's desktop machine. So the where the computation takes place should be, I think, kind of a secondary. So you should build your system so that it can actually both marshal out the computations into the cloud or some grid or some other kind of compute nodes, or you could take advantage of the machines user have. I mean, that's something people kind of these days kind of omitting. Most of our users have really powerful machines, like multi-core. They could do quite a bit of computations locally, so you don't really need to send to the cloud. And this is the case for example, for our traders. They run kind of a really advanced pricing simulations. We could do most of the things there, but for more kind of I would say more complicated scenario analysis, we use the grid computing where we have to kind of distribute the computations over a kind of a cluster of computers, and that's currently is on the AWS as just as an infrastructure.
Thanks, Chetin. So a mixed approach, but making the best of what's currently available in terms of current technologies. Okay, I'm looking at the clock, and we've had quite an extensive and rich discussion. So I think it's time now to bring the webcast to a close. Let me remind everyone again that next week it's Energy Risk USA. All of us here on the call will be attending that conference, so hope we get the chance to interact. I would like to say a huge thank you to today's panel. So we've had the pleasure of meeting Adam Atkinson Lewis from Shell, Glenn Mackey of NRG, Chetin Karakush of BP, Doug Wendler of Machina Automation, and Matthew Seacole from Microsoft. My name's Neil Palmer from Beacon Platform. It's been my pleasure to host this webcast, and I do hope we get the chance to meet again. Thanks also to those who submitted questions. And I would like to draw this webcast now to a close. So thanks again for the contributors, and hope you enjoyed watching. Bye for now.
Thank you to you as well, Neil.